Hello students, welcome to AC Engineering. In this video, we are going to see how the resistors are connected in series and parallel, how to find the equivalent resistors of the same. Now consider the circuit where three resistors of R1, R2, R3 are connected in series and which is supplied with a voltage source of V. Fine. So while it carries a current, let it be some I. Whenever a current flows through the particular resistor, eventually a voltage drop occurs. The particular voltage drop numbered with the same number. If it is an across R1, let it be V1. Voltage drop across R2 as V2. Voltage drop across R3 as V3. Now I try to find the equivalent resistance. It is very simple. If all the resistors are connected in series, means N to N, there is only one path for the current to flow. So the resistance carries same current, but the voltage drop across them varies. Same current, but voltage varies. Same current, variable voltage. So that we can say V1 equal to IR1, V2 equal to IR2, V3 equal to IR3. While making a summation of all the voltage drops, V1 plus V2 plus V3 means all the currents are same current. So take I as common, R1 plus R2 plus R3. So I into this R1 plus R2, R3 is taken as R equivalent. So instead substituting an R equivalent, when a number of resistors are connected in series, then equivalent resistance is equal to the sum of individual resistance. This is the part we need to infer. So that the reduced diagram is given as only one voltage source and the same current. So all the resistors are cumulatively totaled and will name it as an R equivalent. Now we'll see the various applications of series resistor circuit. So when it is connected in a series, in order to increase the total resistance of the circuit, that's why it limits the current flow. So for a fixed voltage Vs, if the flow of current is limited by adding in resistor in series, then it will be results in a voltage division across the resistor. So where we can apply the series resistor circuit, where we need to limit the current flow. Then what are all the effects of resistors? First one, the current remains the same through all the elements connected in series, and voltage division across the element connected in series. The voltage across different elements connected in series depends on its resistance value and the current value. If n numbers of resistors are connected in series, then R equivalent equal to R1, R2 up to Rn. If n resistors are equal to the values are connected in series, then R equivalent equal to n into R. Resistance, voltage and powers are additive in series circuit. This is a very important point. You have to keep it in your mind. Resistance, voltages and powers are additive in a series circuit. The voltage applied is equal to the sum of voltage drops across different elements. If so, what are the limitations of a series circuit? If there is a discontinuity or break in any part of the circuit, then the current flow will not in the circuit. Then a second point, if the voltage gets divided by the addition of element, then the series circuit is not practical for supplying and power in an household appliances, because all the appliances receives a same voltage. So it is not applicable in an household and an industrial applications. Then it is also not practical to connect the devices having a different current ratings in a series. So these are all the limitations of a series circuit, and it is not applicable with an household and an industrial applications. Very important point, you have to keep it in your mind. Then resistors in parallel. Let it be same three resistors via R1, R2, R3 are connected in parallel. Parallel means it's supplied with the same voltage, but the current makes the difference because it connected in a junction point. So it receives various currents via I1, I2, I3. So what should be the equivalent resistance? That is what we have to analyze. So in a parallel circuit, all the resistance have same potential, but draw different currents. Same potential, but draw different currents depends on the value of resistors. So according to Ohm's law, we can write I1 equal to V by R1, I2 equal to V by R2, and I3 equal to V by R3. If the total currents are same, then I is equal to I1 plus I2 plus I3. Means instead I, we have to substitute V by R. All the V's are common. So take it as a common within a bracket 1 by R1 plus 1 by R2 plus 1 by R3. We can say V equivalent equal to V into 1 by R1 plus 1 by R2, 1 by R3. Then V get cancelled. 1 by R equivalent equal to 1 by R1 plus R2 plus R3. So when three resistors are connected in series, then we have to find the equivalent resistance in this way. When two resistors are connected in parallel, then reciprocal of the equivalent resistance is equal to the sum of reciprocal of individual resistances. R equivalent equal to R1 R2 by R1 plus R2. Then we'll see the effects of parallel circuits, means effects of resistors connected in parallel. As well known that the voltage remains same across all the elements connected in parallel. Currents are divided in a parallel circuit. Current flow through each element connected in a parallel depends on its value and the voltage across it. Now the equivalent resistance is 1 by R equivalent equal to 1 by R1 by 1 by R2 plus 1 by R3. If it is happens to be with an n number of resistance is up to 1 by Rn. If n resistors connected in parallel have equal resistance values, then the equivalent resistance is, see, f n number of variable values of an resistors, then this formula holds good. If n numbers of resistors connected but all the resistors carries the same value, means this formula is applicable. R equivalent equal to R by N. Then the last point, the branch current, conductance and paths are additive in parallel circuit. Then what are the advantages of an parallel circuit? Let us see one by one. So in an advantages means if there is a discontinuity or break in any branch, the current will flow in other branches of a parallel circuit. It no way affects the rest of the part of an circuits. Then the electrical appliances having the same voltage rating but different power or current rating can be connected in parallel. That is what we are using in an household domestic appliances. The parallel circuits are used in an household and industrial wiring for connecting the electrical appliances and equipments. So students, I hope in this video you can understand how the series resistors are connected in and parallel resistors are connected in, how to find the equivalence of the same and its limitations, advantages and its effects. Okay, once again, if you can like this video, then it will be trended. So if you wish this video is an useful one, you can make a like and try to share with the needed people. Thank you all. We'll keep on watching the furthermore posted videos regarding an electric circuit. Thank you, students.